Whether you're a global procurement officer, a fleet manager, or honestly just someone who is fascinated by the incredibly high-stakes logistics of emergency medical services, you are in exactly the right place. Welcome to This Explainer. Today, we're exploring the intense world of global EMS vehicle procurement. We'll be drawing heavily from comprehensive manufacturing data and sourcing guides out of China. We are talking about life and death logistics here, where the actual vehicle you choose can completely alter the outcome of a medical emergency.
Okay, let's dive into this because this quote hits the nail on the head. When organizations procure ambulances, they aren't just out there buying trucks. They are literally building model healthcare ecosystems. The choice between, say, a monocoque van body and a heavy-duty modular box, it isn't just about how the vehicle looks when it pulls up to the emergency room. It's a fundamental structural choice about what that vehicle is engineered to actually do. Every single curve, every cabinet, and every chassis choice represents a distinct engineering approach to keeping a human being alive.
So, here is the roadmap for our explainer today. We'll start with Part 1, the EMS vehicle ecosystem. Then Part 2, the anatomy of types I, II, and III. Part 3 covers engineering for life support. And finally, Part 4, matching mission and machine. All right, jumping right into Section 1, the EMS vehicle ecosystem. If you're navigating the modern manufacturing landscape, and particularly the really robust export market over in China, it requires a crystal clear understanding of specific vehicle designations. An ambulance's classification is its destiny, period. It totally dictates the vehicle's mission capability, its structural durability, and its interior ergonomics. For those of you making global procurement decisions, this matters immensely. You're making logistical choices that directly impact paramedics out in the field and patients in critical condition. You have to know exactly what kind of environment your medical personnel are stepping into the second those rear doors fly open. Let's break down those physical shapes in Section 2, Anatomy of Types I through III. What's truly fascinating is the sheer scale of the Type 1 ambulance. It's often referred to as the heavy-duty mobile ICU, and it is built on what's called a chassis cab platform. So think of your heavy-duty truck chassis, like the Iveco Daily, or even specialized 4x4 platforms. The manufacturer takes a separate, custom-built modular compartment, which is literally a heavy-duty box, and mounts it right onto the back of that truck. Because of this specific design, you get perfectly square vertical interior walls. This is huge because it maximizes the interior volume for mounting heavy advanced life support equipment and vertical oxygen manifolds. Interestingly, though, the connection between the patient box and the driver's cab is usually quite limited, often just a tiny pass-through window or a communication hatch. Now, in stark contrast to that giant box, we have the Type 2, also known as the Agile Urban Sprinter. Here, the medical interior is built directly within the original manufacturer's van shell. So the cab and the patient area are entirely integrated into one continuous body. Because it retains its original van shape, a Type 2 vehicle gives you much better aerodynamics, better fuel efficiency, and crucially, a significantly tighter turning radius. This right here makes the Type 2 the absolute backbone of urban EMS, primarily tasked with basic life support missions and rapid response patient transport through heavily congested city traffic. And finally, we have the Type 3, the integrated modular hybrid. This design brilliantly combines the massive interior space of the Type 1 with the accessibility of the Type 2. It uses what's called a cutaway van chassis. So the modular box is mounted to the back, but the cab is cut away to provide a large walk-through connection between the driver's area and the patient compartment. This is a total game changer. It allows the medical team to move freely between the cabin and the patient without ever having to exit the vehicle. If you are running high-acuity neonatal intensive care or really critical cardiac transfers, that seamless, uninterrupted workflow is absolutely essential. And this brilliantly illustrates that critical decision matrix. It lays out exactly how buyers align payloads and optimal missions with specific chassis types. Looking at the numbers, the Type 1 can handle massive payloads of over 3,500 kilograms, making it perfect for rural areas or heavy mobile ICUs. The Type 2 is much lighter, handling around 800 to 1,200 kilograms, which secures its spot as the undisputed champion of urban basic life support. And then the Type 3 sits right in that sweet spot, right? It offers a high payload of 1,200 to 2,000 kilograms, along with that crucial walk-through access, making it the go-to for advanced life support and NICU missions. Moving on to Section 3, Engineering for Life Support. Now we are pivoting from the visible physical shapes to the invisible engineering. When you're sourcing from high-tier manufacturers, the engineering goes way beyond just slapping some cabinets into a van. Modern ambulances are literal marvels of integrated technology.
For example, negative pressure engineering is paramount, especially when you're dealing with infectious disease transport. Advanced units maintain a highly controlled negative pressure environment. This ensures air flows from the driver's cab, through the patient area, and out through a HEPA filter, keeping the whole environment completely sterile. Then you've got electrical redundancy. Intelligent CAN bus systems, which act as the vehicle's central digital nervous system, offer centralized control over lighting, climate, and oxygen, all backed up by integrated lithium-ion battery banks. And structurally, manufacturers are constantly balancing rollover safety with strict weight limits. Type 1 and Type 3 boxes use all aluminum sand paneling for high structural rigidity during rollovers, while Type 3 conversions utilize lightweight composite materials to make sure they don't exceed the gross vehicle weight limits of the original van chassis.
1,500 to 3,000 watts. To put that into perspective, that is a serious amount of power. That is the capacity of the pure sine wave inverters that come absolutely standard in these medical vehicles. You see, an ambulance requires a completely independent power grid. You've got highly sensitive, life-saving ventilators and monitors back there that demand clean, consistent power. These massive inverters, combined with those lithium-ion banks we just talked about, allow for hours of crucial equipment operation without the driver even needing to idle the vehicle's engine. So you might be wondering, why is the international market increasingly turning to China to source these vehicles? Well, the source data points to several really strong strategic advantages. China has developed a highly mature automotive supply chain that offers a ton of diverse OEM platforms. Whether you need an Iveco, a Ford, a Mercedes, or a Maxus chassis, they have it. They offer deep customization capabilities that are tailored directly to local EMS regulations and flexible configurations that range from basic transport all the way up to advanced ICUs. Add in highly competitive manufacturing costs and their extensive export-oriented production experience supplying regions across Southeast Asia, Africa, the Middle East, and Latin America, and it becomes a very compelling option for international buyers. Which brings us to our final part, Section 4, Matching Mission and Machine. Ultimately, choosing an ambulance type is a really delicate balancing act. You have to balance your geography, the medical acuity of your patients, and of course, your budget. Let's contrast two vastly different mission profiles to see how this works. If your mission is metropolitan rapid response, a Type 2 van is the industry standard. Its smaller, tapered footprint allows it to easily navigate narrow city alleys and squeeze into tight hospital parking structures. But if your mission is mobile intensive care, a Type 2 simply isn't going to cut it. You need the Type 1 or Type 3. Why? Because physically mounting 3 to 4 infusion pumps, a heavy-duty ventilator, and a multi-parameter monitor on a wall requires the vertical, square space and serious structural reinforcement that you can only get inside one of those modular boxes. But here is the absolutely crucial takeaway. No matter which mission profile you choose, safety and compliance are the absolute baseline. Professional-grade ambulances undergo incredibly rigorous G-force resistance testing. The engineering behind the interior cabinets and the stretcher mounts is specifically tested to withstand extreme high-load forces. Because think about it, in the chaotic, high-speed environment of an emergency response, a crash is always a risk. This engineering guarantees that in the event of a severe accident, a heavy piece of medical equipment never becomes a deadly projectile. Patient and crew safety is quite literally built right into the walls. And to ensure this level of safety, procurement experts always align their purchasing logic with established regulations, specifically these big three: the European EN 1789 standard, the US Federal KKKA 1822F specification, and the Chinese GB/T 1935-9 standard. Strict adherence to these codes is exactly what separates a specialized, life-saving medical vehicle from just a simple commercial truck retrofit. I want to leave you with this provocative thought as we wrap up our explainer today. Our source FAQ notes something really interesting. While those roomy Type 3 ambulances are incredibly popular across the US and Europe, their wide modular footprint can actually be a massive hindrance in densely packed Asian cities with super narrow streets. So as global megacities continue to grow more congested by the day, will the spacious Type 3 eventually lose out to the agile Type 2 van? Will the literal, physical, concrete limits of your city ultimately dictate the future shape of your life-saving fleets? It's a massive logistical puzzle for the future of emergency healthcare. Thank you so much for joining me on this deep dive into EMS vehicle procurement. Keep learning, keep questioning, and I will catch you on the next explainer.